Well, welcome everyone, and today we're going to talk about what I call not less than a revolution, hardware timestamping era. Um, so my name is Dotan Levy. I'm an architect at NVIDIA, responsible for time and synchronization features. And I want to thank Elad for the co-work that is done with me on that. And what you should expect when you buy a network adapter or build an infrastructure. Something happened with the presentation. Just a second. Okay. So once upon a time, this is actually maybe the situation that you are familiar with. Just synchronization, maybe in the most moderate way, was something very exotic. In niche markets like FSI or industrial, and not in wide spaces or big spaces like hyperscalers and data centers and so on. And even if the telco, which is a big market with big deployment, with big huge amount of equipment, it wasn't accessible for I would say software and open Linux and those things. But and for that reason, I think this is the reason that accurate timestamp support exists only on non-commodity adapters. And so what has changed? A lot has changed, but let's talk about the motivation that happens to this to change. It will make this statement more trustworthy. Two major things. One is the telco market, and mostly the 5G era. There is a big trend towards commodity server and softwareization. You can hear this buzzword almost in any conference. In the latest DPDK summit, there were 30% of the participants were coming from the telco market, talking about allowing the telco edge to be run on commodity server and DPDK offloading some of the telco workload. This is now a big trend. There is another aspect that the 5G itself require a huge amount of infrastructure investment, and this infrastructure investment must come with an architectural change that will allow the service provider to fund this huge amount of hardware that they need to deploy. And one of the key enabler for that is to allow interoperability and softwareization, because there with that you can reduce the amount of TCO spent on the application. You can have a free market. We actually see that. I mean, as NVIDIA, as a vendor for this market, we see that this is a big trend. The second thing, as I think Georgie lecture was great articulating this, is the data center applications kind of hitting a performance barrier that can be solved with synchronization. And the reason is that we are in the era of large scale, in a scale that a single data set of data is not in a silo anymore. And once you don't treat it the compute to be local, then you start to hit those synchronization errors. You need to lock your assets. You need to synchronize the access to atomic to a common resources and so on. So we believe that synchronization is going to be a big thing in the next few years. And what we have today already in the NIC, you can expect hardware timestamp. I will elaborate what you can get, and the timestamp format, which is not equally important, by the way. Okay, so hardware timestamp is gives you an accuracy under any network or CPU load, because it's hardware, it's not biased. It's more accurate than the software because it's layer 1 and layer 2, but nevertheless, it's also immune to the network load or the CPU load. I would say that it also can be, also if designed properly, it can be also immune to environmental changes. But there is a big difference between receive and transmit. And the reason for that is that commodity software, commodity network adapters, the ones that are deployed in millions in data center, communicate with the software in a massive manner. And when you timestamp a packet, it's not the problem is not to timestamp it. The problem is to tell the right software entity and only the right software entity, because we are secured, that what was the timestamp on which specific packet. So on the receive side, it's rather easy. You timestamp a packet, the timestamp can carry on with the packet, and when the software receives the packet, it can read the timestamp from the hardware descriptor or whatever that the hardware is writing along with the packet. So you can expect a few nanosecond accuracy, depends on flavors of NICs, and you theoretically can have any packet being timestamped. You don't need to ask only for PTP packets to be accurately timestamped. All the packets that goes in the NIC can be timestamped. We will see soon what is the benefit from that. On the transmit, the story is much different because theoretically, if you remember the basics, we want to timestamp the packet as it hit the wire, like at the very last end of the SERDES. But when we reach that point, there is no connection in the network adapter pipe to the software, because the packet does not belong anymore to the queue that sends it. It's on the underlying physical layer. And there are a lot of challenges in that. And from that reason, you can still get a sub microsecond, because we practically timestamp it a bit earlier, and it will not be for a full wire speed, but it's still a good timestamp. Now let's talk about the hardware timestamp format. How does hardware timestamp work? So theoretically, the network adapter doesn't know what is the actual time. They have a local free running clock running inside. And there is a timestamping agent that's supposed to be synchronized within the network adapter. This timestamping agent, timestamping a packet, for example, put 5,000 as a timestamp on this packet. This packet traverses to the software. When the software reads the packet, the software needs to do some kind of conversion. This conversion is taking into consideration the adapter frequency and the boot time in order to convert this 5,000 to 8 a.m. this morning. And then the packet goes to the application. In this case, I'm emphasizing the PTP4L. The PTP4L take the timestamp, calculate all the servo operation, and understand if the clock is behind, whether there is a phase error or a frequency drift, and if any sends command to adjust the time or the frequency. While I don't know if you are aware to that, in that case, the adjust time and frequency command doesn't go directly to the hardware. They go to the driver that change the conversion formula in order to accommodate this change frequency adjust time commands. And every step in this flow introduces inaccuracy error. There is a small inaccuracy error in the timestamping itself. There is an additional error in the conversion, and there is an additional error over the application, which belongs to the distance of the control loop and the algorithm, which does not anticipate correctly whether this packet may be an outlier or a long variation of the pipe, etc. But now network adapters behave a bit different. Um, the network adapters can run the real hardware clock, the real UTC, for example, or TAI, whatever timescale you are running. And actually, the PTP4L can discipline the hardware directly. That means two things. First, we completely eliminated the error that the conversion in the driver was introducing. And second, um, it's a big added value when the application can get directly the UTC time format from the hardware, because now there is no performance hit when you will ask for this timestamp service to be deployed in any application. There is no, if you want your application to get an accurate timestamp, you don't need to request for Linux translation service. You can still do a kernel bypass or anything similar in this manner in order to accommodate that. And that's what, this is what allow you to do, to get accurate timestamp for any application. We see it as a big change that enable a lot of workload to be more precise. And actually, we expect more to come, so stay tuned on that. As I said, the application doesn't need a kernel service for translation, and timestamp becomes like a service that we can provide to application and not just for the infrastructure. It's more accurate, it less variant in temperature. And another nice thing is that the timestamp are agnostic to the protocol encapsulation, because the conversion is not done by software that needs to parse the packet. It's kind of the metadata regardless of the packet format. So it's actually should support any PTP profile or anything that you want. Now, what we think we should do starting now, thanks to this knowledge, when you choose your network adapter vendor, you should request for hardware timestamping capability. This will be a huge part of the future infrastructure as we anticipate. If you follow us, this is a big must. And then, thanks to the fact that accurate timestamping can reach out to your application, try to see how can your application workload be enhanced or offloaded using tight synchronization. And the first step would be, from my point of view, to join our project app. We will continue to explore more and more applications that will dramatically be offloaded with that service. With that, I would like to thank you, and Elad, if there are any questions.
Thank you, Dutan. No questions for this one. There is a question from Alon Regev, Keysight, on the previous presentation. How about you tackle this one? Many NICs provide virtualization support, but the 1588 subsystem is not virtualized. Any plans or thoughts on this?
Well, actually, it's a bit related to what I just presented.
Right.
The fact that the hardware timestamp is agnostic to the packet format, it's also agnostic to the overlay. This is only one aspect of virtualization, I know, the overlay, but trust me, we tackle the rest of them. The hardware supports everything that is needed, and we are working on a software solution that will allow it. Virtualization that can enjoy a PTP stack. Yeah, that's definitely one of our goals.
Thank you, Dutan. No further questions.